How you doing, pre-algebra? Today we're going to be talking about like terms in the distributive property and how those are connected together to help us solve problems. Really what they're used for is simplifying things first before we get into solving like we have been doing over the last month. We know when we solve for a variable, we want to find out what number goes in for that variable to make the whole equation true. I will use like terms in the distributive property to help reduce it down so I can get back to one of those simple problems like we were doing over this last month. So, or I should say simpler problems. So let's get started and look at this. First thing I want to look at is what does it mean by the like terms? Well, what a term is a portion of an expression or an equation. Terms are connected. I got to take that out. Are connected through addition, subtraction, and the equal sign. So when I look at this problem, the 4x is a term. The 3 is a term. They're connected by a plus sign. The 9y is a term. The 4x is a term. Now when we get to this last part here, I got a minus 9.5x. That's really a plus negative. So the negative 9.5x is a term. So really when I look at it, it is connected by addition or subtraction, but it's really the addition that we're wanting to find. So if it's a subtraction, we got to think of it as being a negative number there. Okay, so now what do we do with those? The like terms are in an expression, anything that has the same variable. So let's take a look at this part right here, this right equation. The 4x and the negative 9.5x are considered like terms. They both have just a single x value. So that makes them like terms. So what do we want to do with these? We want to combine these like terms. Well, what that means to do is that I need to add or subtract those variables there, or not the variable, the number in front of the variables. We call that number a coefficient. So what I do is, in my 4x and my negative 9.x, I go ahead and hook those together. I take 4 minus 9.5, or I can take 4 plus a negative 9.5. Either way, I get a negative 9.5x. So that means that whole equation, that was 9y plus 4x minus the 9.5x, reduces down to just be the 9y, it's got no buddies, so it can't hook on anything, minus 5.5x. That's what it is. So let's see some of these problems in actions. I've got a 10k plus a 9k in problem number 1. Well, all I'm going to do is take the 10 plus 9, and that gets me a 19, and then I have a k. Think of the k just like we did when we had our hands-on equations. They were just the stars or the x's, the little pawns. How many of those did I have? We have 19 in this case, which is why we can't use our systems. Okay, for problem 3, I got a 4x and I have an 8x. I'm supposed to add those. So 4 plus 8 is 12. So I've got 12x minus 1. Well, now on number 5 here, I got 8x, and I'm supposed to take away 3x. Well, what is 8 take away 3? It's 5. But I still have an a. Okay, number 7 is a little trickier because I have a 1 that I'm supposed to add 8 to, and I got this 5r that I'm supposed to subtract 6r from. So 1 and 8 get me a 9. 5r plus a negative 6r, or minus 6r, is a negative 1r. Or if I just write that as 9 minus r. Either would be fine. Now when I look at number 9, it says I got 9b, I'm supposed to take away b. That is not 9. I can't just take away the b. I got 9 b's take away 1 b. That means I got 9 take away 1, which means I have 8 b's. So when you think about this coefficient, that number that's in front, it tells you how many of those variables do you have. I had 10 k's in one group, 9 k's in the next group, so I have a total of 19 k's. So in problem 9, I have 8, I got 9 b's. So I can write them out as 9 different b's, and then I got to take one of them away. It leaves 8. Okay, so that's combining our like terms. Now we have the distributive property. The distributive property is a way to simplify an expression in which a number is in front of a parenthesis group, such as what I have right here. I've got a 4 parenthesis 2x minus 3. How do I do that? Well, one way to look at that is I've got 4 of these 2x minus 3 groups. So that 4 parenthesis 2x minus 3 is just a 2x minus a 2x minus 3 plus a 2x minus 3 plus a 2x minus 3. Now I combine my like terms. I've got 4 of the 2x's, 2x plus 2x plus 2x, so 2 plus 2 plus 2 plus 2 plus 2 is 8x. And then I got the 4 negative 3's, and I got 4 of them together, I get negative 12. So I get 8x minus 12. So I have 4 times the quantity 2x minus 3, or 4 of those groups, is the same as 8x minus 12. Now notice 4 times 2 gets me 8, and 4 times negative 3 gets me the negative 12. So that number out in front is just multiplying both things inside. Another way to see this is if I draw it like this. That 4 on the outside multiplies to 2x, and it becomes an 8x. That 4 on the outside multiplies that negative 3, and it becomes a negative 12. Okay, so that's the way to look at that as well. So I'm taking that number on the outside and multiplying both things on the inside. So let's try a few problems like this. Notice the directions haven't changed, still simplified. I've got 7 of these 6 plus 2x groups. I could write it out as 7 of them, and then go ahead and add all the things up, or I can take the 7 times the 6 and get 42, and take the 7 times the 2 and get a 14, and that's a positive number, so that's an x. So positive 4, so 42 plus that. Okay, I can do the same thing here. I'm going to take 2 times the 3x, or a 3n, which gets me a 6n. And I can take 2 times the 3, and that's a positive 6. Now I can take 3 times a n, and that gets me a 3n. I can take a 3 times, now consider that a negative 3. Now when I look at it, I'm looking at this whole thing, that's a negative 3. 3 times negative 3 is negative 9. So I can think of that minus as a minus sign, or I can think of it as a negative. And when I go to do the distributive property, I'm going to think of that as a negative when I'm doing my multiplication. So on 17, I got 6 times a negative 4, which is a negative 24v, and 6 times the 8, which is a positive 48. Okay, so in all these examples so far, I have a positive number sitting outside. So I could rewrite them as if they were that many groups of whatever's inside the parentheses. How do I do it if I have a negative on the outside? I'd have to think of it as I need to subtract 5 of these groups, which makes it a lot harder to do. So we want to do it through that multiplication. I got the negative 5, and I need to multiply the 5k. Well, negative 5 times 5 is a negative 25k, and negative 5 times this whole quantity, notice that's a negative 8. Negative 5 times negative 8 is a positive 40. So that's how that distributive property works. It's the multiplication of both things inside by whatever's on the outside. Or you can think of it as groups, and in this case I had to take away these groups. I had to take away 5 groups of 5k, which means I have to take away 25k's, and I had to take away 5 groups of a negative 8. Well, that means I had to have a positive 40 there to go. So it's easier to do it through the multiplication. Now, the next step here is, what if we have problems where we have to combine both things? So what if I have problems like these, where I have both a like term and I have to work through it? Here's the first thing to notice. According to our order of operations, or PEMDAS, or JEBDAS, whatever you want to call them, I have to do the multiplication before I can do anything else. I have to take this part first before I can deal with the negative 4. So I've got a negative 4. Now let's deal with this. I got a negative 3 times 8, which is a negative 24. I've got a negative 3 times a negative 5, which is a positive 15v. Now I look for any like terms. The negative 24 and the negative 4 are like terms. So I'm going to go ahead and combine those. Negative 4 minus 24 is a negative 28 plus 15v. Likewise, on the next problem, I have to take the number on the outside, and I'm going to take it to both of those things on the inside. This is a negative 3k, and now think of this whole thing as a negative 1. So a negative 3 times a negative 1 is a positive 3. Now I've got to subtract 8k. Are there any like terms? Why, yes. The 8k and the 3k are like terms. They're both negative numbers, so I'm going to go ahead and take a negative 3 and add a negative 8, which gets me a negative 11k plus the 3 that's left there. Okay, let's look at the next problem. I've got a 2 and a 7k plus 6. So I could make it 7k plus 6 plus 7k plus 6 plus 5 and go ahead and add this 2 groups of 7k's and then the 6 to 6 and the 5. Or I can do it through this distributive property, which says to multiply both of those by that 2. So 2 times 7k is 14k. 2 times 6 is a positive 12. And then I have that plus 5. So I got a 14k. And then these are my like terms, plus 17. Okay, again, here I have one of those problems where I've got a negative number on the outside that I've got to multiply to both things on the inside, and that second part's a negative number. So I have the negative n. Negative 7 times 5 is a negative 35. Negative 7 times a negative n, two negatives multiplied, is positive 7n. So now I'm looking for like terms. I got a negative n and I got a positive 7n. I have 7 n's and I got to take away 1 n. That's what that first n is saying. So that leaves me with 6n minus 35. Okay, one more example problem here for you. And then I'll turn you loose to do the assignment yourself. I've got a negative 7x minus 10 of these x plus 4 groups. So we're going to work it through the same way. I'm going to take this negative 10 times the x, which gives me a negative 10x. I'm going to take this negative 10 times this positive 4, which is a negative 40. And I'm going to bring this one down. So I got a negative 7x minus 10x minus 40. Well, these two are like terms. So a negative 7 and a negative 10, they're both the same sign. I go ahead and add the numbers. So it's a 17. It stays negative. X minus 40. Okay, so that's our like terms in our distributive property. I want you to do the other 15 problems on this worksheet.